Yan. So, welcome no to our very first lesson in differential equations. So, let us talk about introduction to differential equations. In this lesson, we will be learning the fundamentals, no, the terminologies that governs, no, the concept that governs the study of differential equations. Okay, so game, let us start. So, let's first review what is an equation, no. So, sabi dito, the equation or an equation is a mathematical statement that shows the equality between two expressions via an equal sign. So we have two expressions, no? Both they are placed on the left side and the right side of the equal sign, and that equal sign signifies the equality between two expressions. No, so for example, no, we have here ito yung ating mga equation. So let us identify what are the types of equation that we have here in our presentation, no? So first, okay, so yung una natin is an algebraic equation. That is obvious naman, no? So we have ax squared plus bx plus c. Actually, this is the general form, no, of a quadratic equation, no? So that is an example of an algebraic equation. An algebraic equation are equations that involves one or more variables, no? So we have, in this case, we have x. Okay, so then we have here, no, yung ating pangalawa, we have a sine omega t minus b cosine omega t is equal to c e raised to t. No, so kung mapapansin natin, we have trigonometric and exponential functions involved in the equation. So this type of equations are what we call transcendental equations. Okay, so transcendental equations are equations that involves transcendental functions. Ano ba yung mga transcendental functions natin? We have trigonometric, inverse trigonometric, hyperbolic, inverse hyperbolic, exponential, and logarithmic functions. Now, yung pangatlo naman, so we have x is equal to t and y is equal to t squared for t is greater than negative infinity but is less than positive infinity, no? So yung mga ganitong klaseng equation, this is what we call a parametric equation. So meron tayong parameters na binibigay, no, in order to validate the value of the equation. And our last, no, yung ating huling example for the equation, we have b sub 0 of x, no, multiplied to d squared y over dx squared, no? So the second derivative of y in respect to x, no? Then we have plus b1 of x, no, of the multiplied to dy over dx plus b2 of xy is equal to q of x. Okay, so this kind of equation, so as we can see now, we have our function y and we have the derivatives of y, the second and the first respectively, no? So this is what we call a differential equation. Okay, so what is a differential equation? A differential equation is defined as an equation involving derivatives of the unknown functions where the function and its derivative are evaluated at the same point. So, dapat present, no, both the function and the derivative at the same time. Hindi pwedeng derivative lang and of course, hindi pwedeng functions lang, no? So, evaluated sila at the same time, at the same point. Okay, so that is what a differential equation is, no? So, we have here, sorry. We have here examples of differential equations, no? Ito yung mga different examples lang naman to, no, ng mga differential equations that we know, no? For example, we have dy over dx is equal to cosine x. No? So obviously that is a differential equation. We have we have here the function y, no, and yung ating derivative, no, in respect to x. Then we have d squared y over dx squared plus k squared y is equal to 0. No? So that is another example of differential equation. Then we have x squared plus y squared dx minus 2xy dy is equal to 0. That's another differential equation. Then we have here yung pang-apat natin, yung partial u in respect to t is equal to h squared multiplied to the second partial of u in respect to x plus second partial of u in respect to y. And we have we have here, no, yung sa last equation natin, we have L multiplied to the second derivative of I in respect to T plus R multiplied to the first derivative of I in respect to T plus 1 over C multiplied to I is equal to E omega cosine omega t, no? So this is another example of differential equation. Particularly, this is a LRC, or the inductor resistor capacitor equation, no? Yung relationship ng tatlo kapag kinukuha natin yung value ng ating voltage, yun yung E omega, no? Yung E omega cosine omega t, that is the yung output voltage, no, as we can say. Okay, so let's focus on this particular on this particular differential equation. Okay, so we have the so-called independent variables, dependent variables, and parameters. No, so yung independent variables natin, so those are the functions that those are the variables that the functions are being differentiated to, no? So for example, we are differentiating I in terms of t, so therefore the independent variable is t, no? So yun yung independent variable natin. Then we have our dependent variable, that is the function, or that is the variable that we are differentiating with, or to, not differentiating with, yeah, technically. So in this example, we have our dependent variable as I, no? So, and we have parameters, no? So yung mga parameters natin, these are values, or these are variables that directly or inversely affect the behavior of the function. In this case, no, ano yung mga parameters natin dito? We have LRC, obviously. Then we have E omega. Okay, so yun yung ating mga parameters in this given example. Okay, so yeah, no, basically that's what that's what a differential equation is, the composition of a differential equation, no? So let's proceed with the order of a differential equation. So the order of the differential equation, it is defined as the highest derivative, or the differential coefficient of all derivatives present in the differential equation. So we have mainly we have two categories, no, of the order of the DE. So we have first order DE and higher order DE, but the higher order DE is subdivided, subcategorized into its particular order, no? We have second order, third order, fourth order, so on and so forth. Okay, so yun, that is what an order of the differential equation is, no? That is the highest derivative, no, in the given, no, in the given differential equation. For example, no, so we are asked to find what is the order of the following differential equations, no? So we have here, no, we have three examples. We have dy over dx plus p of xy is equal to q of x. We have d squared y over dx squared plus 3x cubed plus 3x multiplied to y, no, quantity multiplied to y is equal to 9. Then we have d squared y over dx squared plus dy over dx quantity squared, all the quantity raised to 4, no, yung buong quantity, is equal to k squared multiplied to the third derivative of y in respect to x quantity squared, no? So yun. So let's first determine yung una, no, ano ang order nitong differential equation natin. Sabi natin this is the highest derivative, no? So obviously we only have one derivative, that is dy over dx. So hence this is this falls under the first order DE, or DE of order 1, no? So yun yung ating order for this differential equation. Next, we have d squared y over dx squared plus quantity of x cubed plus 3x multiplied to y is equal to 9, no? So obviously, this is a second order DE, no? So yung pinakamataas it's the lone, no? Yun lang yung nag-iisang derivative natin. We have d squared y over dx squared, no? So that is DE of order 2. Then we have our third example, no? So tatlo yung ating derivative, no? Let's inspect. We have d squared y over dx squared, so that's second derivative. We have dy over dx, that is the first derivative rather, and we have d cubed y over dx cubed, so that is the third derivative. So since third yung pinakamalaki natin, obviously this is third order DE, or DE of order 3. No, so yun, no? So that's the order of the differential equation. Okay, next, let's talk about the degree of the differential equation. So sabi dito na defined as the related exponent or power of the highest derivative in the differential equation. So the degree is basically it's the exponent of the order, no, yung order ng ating differential equation. The differential equation must be a polynomial equation in form for the degree to be defined. So not necessarily we have the 'di ba? For example, nakakuha natin na yung exponent ng highest derivative in the function. However, in the equation, no, it is not in polynomial form, no? Ano yung ibig sabihin natin for the polynomial form? So if the DE is not in polynomial form, the degree is undefined. So yun yung gusto lang sabihin, no? Kapag hindi siya naka-polynomial form, undefined yung ating degree. Paano ba natin mako-consider if the polynomial is, I mean, if the DE is not in polynomial form? So first we have or one derivative is an internal function of transcendental functions, no? So yung mga trigonometric functions natin, etc. Okay, kapag nasa loob yung ating mga derivative or yung isa, kahit isa lang, no, sa ating mga derivatives is automatic, wala na siyang degree. Then we have here, no, yung pangalawa is not free from radicals. So ever, itong part na to, yung not free from radicals, this is actually manipulable, no, kung may term man na manipulable, meaning pwede nating i-rearrange, no, by of course by abiding with the basic algebra laws, no. So pwede natin siya i-manipulate for us to determine what is the degree, no, kasi pag naalis na natin yung radical, pwede na natin kunin yung degree ng differential equation. So for example, no, gamitin natin yung kanina. So what's the degree of the following DE? No, so yan yung example natin kanina. So for the first one, so again, no, the order is 1. So ito yung dy over dx. So ano ba exponent na tong function na to, or rather na tong derivative na to? No, so obviously that is 1, no? Degree 1. Kasi wala namang exponent nakikita, di ba? So yung pangalawa naman, so again, no, the highest derivative is this one, d squared y over dx squared. However, the exponent of the derivative itself is also 1. So hence this is also degree 1. Okay, then yung ating pangatlo, no, so ito yung highest natin, d cube y over dx cube. However, naka-quantity square tayo dito. No, so ibig sabihin, 2 yung exponent ng ating order, therefore this is degree 2. No, so yun. Okay, so another example. So, yeah, meron tayong tatlo, no? So, we have, first, yung dy over dx is equal to tangent x plus y, no? So, this is of degree 1, obviously, no? So, nakahiwalay naman yung derivative natin sa trigonometric function natin. However, etong pangalawang example natin, the tangent of dy over dx is equal to x plus y. This is undefined, no, wala tong degree. Bakit? Kasi nga yung ating function, no, yung ating yung ating derivative is inside a transcendental function, no. So nandoon siya sa loob, meaning hindi natin siya pwede kunan ng degree, no. So kaya siya no degree or undefined. Also now, atong ating last example, we have d cube y over dx cube plus cosine of d squared y over dx squared is equal to 5x. So this is also undefined. No? So, yun lang naman yung gustong sabihin ng ating yun sa ating exception, no, for the degree of the differential equation. Okay, so we have two types of differential equation. No? We have ordinary differential equation. So these are DEs whose derivatives are just regular, no, or ordinary derivatives. Yung the usual natin na nakikita, dy over dx, d squared x over dt squared, no. So yun yung mga ordinary differential equations natin. For the partial differential equations naman, so these are differential equations whose derivatives has at least one partial derivative. So ano ba yung mga partial derivative natin? Ito. No, sorry, this should be partial, no. Ayan, i-correct nyo na lang. So the partial of z in respect to x, then yung ating pangalawa is partial ng second partial ng z in respect to t plus second partial ng z in respect to u. So yun yung mga sample ng partial derivatives natin. Okay, so again, this is partial, no. Ito yung symbol for partial, no. I-correct nyo na lang. Ayan, hindi ko napansin. Okay, so linearity, no? So this is one important aspect of differential equations kasi it is actually quite hard or different rather to solve nonlinear differential equations as compared to linear differential equations, no? So dapat mag-fall under this format, no, yung ating differential equation for it to be called a linear differential equation. So for the ordinary, no, pagka meron tayong OLDE, no, so yung ating ordinary linear differential equation. So, the form must be a function of p in respect, I mean, p of x, no, basically p of x multiplied to d raised to n y over dx raised to n, or the nth derivative, no, of y in respect to n, plus p sub 1 of x, no, so that is function of x again, the n minus 1, no, n minus 1 derivative of y in respect to x, basically, no? So yun yun. Then up until p sub n minus 1 of x dy over dx, no? Then plus p sub n of x multiplied to y is equal to q of x, no? So let's dissect, no? Let's dissect. So we have p, yung ating mga ano, no, functions natin. We have p sub 0 of x, p sub 1 of x, no? So those are just regular functions that are in I mean, yung variable is x basically, no? So yun lang naman yung p sub 0 of x natin. Then yung q of x is another function of x, no? Then dapat daw yung mga derivative natin, no, should not have an exponent greater than 1. Okay, so ibig sabihin, pwede silang pwede mawala, no, yung mga other derivatives. So, however, hindi siya pwede magkaroon ng exponent. So hindi siya pwede maging, let's say, no, d squared y over dx squared quantity squared pa ulit, no. So automatic non-linear na 'yon. No, so yun. Then we have your partial linear differential equation. So ganun din, no. It just follows the same format, no. Mas marami lang yung variables natin for partial differential equation kasi multivariable calculus nga ito, no. So ayan, no. So yan yung ating format na sinusunod. So ganun ulit, no, dapat yung ating mga partial derivative must not have an exponent greater than 1, at saka yung ating mga functions should only be a function of the differentiating variables, no. So in this case, x and y lang naman, no. So dapat yung ating functions must only be a function of x and y basically. Okay, so that is the linearity of a differential equation. Okay, so let's try to analyze. However, no, note muna pala, no, so for ODEs or different, ito yung sinasabi ko kanina, no. So p of x or q of x can be a function whose variable is the same as the differentiating variable, no. So in this case, no, if dy over dx yung ating derivative, then x yung ating differentiating variable, or pwede din siya maging constant. Okay, for PDEs ganun din, katulad nga ng sabi ko kanina. So dapat kung if we are getting the partial derivative in respect of x and y, dapat yung mga functions natin should only possess variables of x and y, or it is a constant. Okay? So, yun. Example. So, determine if ordinary or partial, linear or nonlinear, then the order and the degree of the equation. So, we have d squared x over dt squared plus k squared x is equal to 0. So, obviously, no, we have second derivative. So, ayan. Then, degree natin is 1, no? Or is this an ordinary or partial differential equation? Obviously, this is an ordinary differential equation, no? So, ayan. This is an ordinary DE. Then, of course, this is also linear, no? Ayan, linear siya. So, wala naman tayong makikitang other variables, no? Yung k naman is a constant, no? So, wala naman tayong issue dyan. Then, we have DE of order 2. No? So, of course, second derivative. So, second order, no? Then, degree 1. No? Kasi wala naman tayong exponent, no? I mean, may exponent, pero 1 lang naman yung exponent ng derivative natin. Okay, so next example, we have the second partial of z in respect to x is equal to alpha squared, no? So alpha squared, second partial of z in respect to y, no? So obviously, kakabanggit ko lang, this is a partial differential equation. This is a linear differential equation. Bakit? 'Di ba, constants yung mga numerical coefficients ng ating function, ng ating derivatives rather. Degree of order 2, no? So the degree is ayan, no? So obviously second derivative, then degree 1, no? So yung ating mga partial derivatives naman ay walang exponent. I mean, may exponent pero 1 lang na may exponent niya. Okay? So yon. Next. Oops. So sige, we have here the given x squared plus y squared multiplied to dx plus 2xy dy is equal to 0. Na yun yung given natin. However, actually it is somehow quite hard, no, to determine if it is linear, no, let's say, kasi ordinary madali lang eh. Of course, you're just dealing with regular derivatives, and particularly order and degree, no, kasi kailangan muna nating ma-isolate, no, yung ating derivative dy over dx, no, before we proceed with the order and degree. Okay, so we have here, we can manipulate this algebraically. So yung dx pwede nating i-divide, no, para ma-isolate natin yung dy, I mean makakuha natin dy over dx basically. So we have, kapag na-divide na natin by dx, so we have 2xy multiplied to dy over dx plus x squared plus y squared is equal to 0. So with this, no, it is now easier to identify. Of course, this is an ordinary differential equation. Okay, this is an ordinary differential equation. Then we have ano yung ano natin? This is of course nonlinear, no? So sorry. This is a nonlinear differential equation. So bakit siya naging nonlinear? Dapat x lang yung function natin. May y tayo eh, 'di ba? So ano siya? Nonlinear siya. Okay? Then we have the of order 1. So obviously dy over dx lang meron tayo. So first derivative order 1. Then we have degree 1. No? Wala namang other exponent. I mean, hindi naman greater than 1 yung exponent ng derivative natin. So degree 1 lang yung ating given example. Next, we have y prime plus p of xy is equal to q of x, no? So medyo madali lang to, no? Yung mga y prime natin, this is let's say, no, we can set na this is equivalent to dy over dx, no? So this is an ordinary differential equation. This is a linear differential equation, no? So p of x is a function of x, q of x is also a function of x. Then we have dE of order 1, no? So obvious naman, no? First y prime lang yan, so first derivative order 1. Then we have degree 1. Oh, so, wala namang other exponent yung y prime natin aside sa 1. Okay, then last, we have the third derivative of y minus 3y prime plus 2y is equal to 0. So, if this is the case, no, so, obviously, ordinary, linear, no, so, constants naman yung numerical, I mean, yung functional coefficient ng mga, ano natin, derivatives natin in the function. Then we have dE of order 3. So, bakit siya naging order 3? Y triple prime. Then degree 1. Kasi wala namang other exponent yung y triple prime natin except for 1. Okay? So, yun. No? Basically, that's the end of the lecture. No? So, I hope you guys learned something. No? So, madali pa lang naman to. We're just identifying the governing terms, no, in I mean in that we will be possibly used in solving differential equations. So in the next lesson, no, so we will start discussing solutions to differential equations. So thank you for listening. Stay safe and God bless.